Hello everybody and welcome back. We're on question number 19 of the 2002 Fermat paper. If 2 to the a times 3 to the b is equal to 8 times 6 to the power of 10, where a and b are integers, then b minus a is equal to... Okay. So at first glance, one might think, well, there's not really a way to get a and b out of here, because we've got one equation, this one here, but we've got two unknowns, a and b. Okay? But these aren't linear equations where we're trying to work stuff out. This is a prime decomposition. I make this comment because there was a question, there it is, 16, that I did a while back, where there were only two equations and four unknowns, and I made the remark that you should not expect to get a, b, c, and d out of there. In contrast, this question, one equation but two unknowns, we can actually get what a and b are, because we're told a little bit of extra information that they have to be integers. And if they have to be integers, this turns into a very unique decomposition, something called the prime decomposition. Notice that 2 and 3 are prime numbers. There is a unique way to write any integer as a product of powers of prime numbers. Powers of prime being primes raised to exponents, to integer exponents. So if we can work out how many factors of 2 are in here, and how many factors of 3 are in here, we'll be able to work out what a and b are separately, and be able to do b minus a and perform that calculation. Okay? So this relies on prime factorization. And this is something that is unique for every integer. I'll say positive integer. We don't usually prime factor negative integers. Okay. So, 8 times 6 to the power of 10. Well, 8 is really just 2 cubed, so that's 3 copies of 2 right there. And 6, well, we can prime decompose 6, that's 2 times 3. And that's being raised to the power of 10. Now, outside the bracket, we have an exponent, and inside we have a multiplication. Exponentiation distributes over multiplication, just like multiplication distributes over addition. Okay? It's a distributive law that doesn't come up very often, but it's still a nice one to know. So we still have the 2 to the 3 from the 8, and then we have a 2 to the 10, and a 3 to the 10. Now there's no reason to get these brackets here anymore. 2 to the 3 times 2 to the 10, we add the exponents, 3 plus 10, and the 3 to the 10 is left by itself. So this is the prime factorization of the number we're given, and we want that to be 2 to the a, 3 to the b. So it follows that a is going to be 13, b is going to be 10, and we'll just clear this page right here. We are asked to calculate b minus a. That's going to be 10 minus 13, and that's negative 3. So let's see, is negative 3 among our answers? There it is, right there. It's E. It's at the very end. Just double check. We did want b minus a. Okay, sounds good. So negative 3, or an answer of E on our bubble sheet. Okay. So that's question number 19. We have one more question to go in this part of the contest, and that'll be question number 20, and that'll wrap up part B. We'll handle that in the next video, so I hope to see you guys there. Thank you, as always, for watching, and I'll see you next time for more math.